All right, so today we are going to be talking about graphing an equation given constraints. So take a look at example number 1. 4x minus 3y equals 7 if y is less than or equal to 0. So the first thing that we need to do here is we need to solve for y so that we can graph this. So we solve for y. We see that this is an equation of a line. So we graph using slope and y-intercept. Our y-intercept is 0, negative 7/3, and our slope is 4/3. So from our y-intercept, up 4, right 3, and reverse, reverse, down 4, left 3, and we end up getting that line. Now we need to think about the constraint, the fact that y is less than or equal to 0. So the line y is less than or equal to 0 is actually the x-axis. So we get this line here. So the intersection of our function and our constraint is this coordinate right here, which I filled in with a solid point because we want to know where y is less than or equal to 0. So at that line is where y is equal to 0, and we want that included. So what we need to do now is we need to find that intersection. So to do that, we can substitute in y equals 0. So we substitute in y equals 0, and we solve for x, and we get x equals 7/4. So the coordinates of this point is 7/4, comma 0. So determine the restricted domain that corresponds with the range constraint. So that means that our domain is everywhere where y is less than or equal to 0. So this section here, so everything from negative infinity to 7/4. Again, inclusive on 7/4 because it's less than or equal to 0. Example number 2, y equals 4 log of x plus 10 and then plus 3. And we want a constraint, a range constraint as y is greater than 3. So a logarithm, we're going to graph the logarithm. We know how to graph this without a calculator with transformations, right? So we have our normal logarithm, but it's going to be shifted to the right 10 up 3 with a stretch of 4. You will be allowed to use your calculators on this, so you can also graph in your calculator to get a general shape. So we graph, and we have the shape of our logarithm looks like this. And again, shifted to the left 10. And we want to know where y is greater than 3. So y is greater than 3. Notice this time we have an open circle because it's not greater than or equal to 3. It's just greater than 3. So again, I need to find that intersection. So we find that intersection by substituting 3 in for y. Substitute 3 in for y. Subtract the 3 over. So we have 0. Divide by 4. So we have 0 equals log of x plus 10. Convert it to exponential form. 10 to the 0th equals x plus 10, which means 1 equals x plus 10, which means x equals negative 9. So the coordinates of that point are negative 9, 3. So our domain is everywhere where our range is greater than 3. So everything from negative 9 to infinity. And non-inclusive this time because it's just where y is greater than 3. All right, example number 3. 4x squared minus 9y cubed equals 16. So we have never graphed this type of function before, so we would have to use our calculator for this. So in order to graph this in our calculator, it has to be equal to y first. So we go ahead, solve for y. So subtract the 4x squared over, divide everything by negative 9, and then take the cubed root. Cubed root is an odd root, so we do not need plus or minus. So we put in our calculators, go to our y1, type in cubed root of 16 minus 4x squared all over negative 9. And again, it's okay that it's negative. We also don't know what x is, so it is okay that it's negative. Graph it in our calculator, take a look at the graph, and draw a rough sketch. So drawing a rough sketch of our graph, it looks something like this, kind of like an omega symbol. And we want the domain as long as y is greater than or equal to -1. So we draw in the line where y is greater than or equal to -1. Again, I have filled in circles at the intersection because that is where y is equal to -1. So now I need to find those two intersections. And yes, we are allowed a calculator, but I want you finding intersections by hand, not by calculating the intersection in your calculator. So make sure you can algebraically test these intersections. So we substitute in -1 in for y and solve for x. Substitute in -1, follow our order of operations. So -1 cubed is -1 times -9 is +9. And then move that 9 over. So we get 4x squared equals 7. Divide by 4. So we get x squared equals 7/4. Take the square root, so x is plus or minus square root of 7/4. Again, plus or minus because it's an even root this time with square root. And simplify, square root of 4 is 2. So we get x is plus or minus square root of 7/2. And go ahead, find the domain. So again, we want where y is greater than or equal to -1. So we want this section and that section, everywhere where y is greater than or equal to -1. So everything where x is between -infinity and -7/2, inclusive on the 7/2, or square root, sorry, is 7/2, because it's or equal to. And then again, from square root of 7/2, inclusive to infinity. And example number 4, y equals 1 plus 4 to the x if y is less than 6. So again, we don't necessarily need a calculator to graph this. We know how to graph exponentials without one. So we have an exponential curve that shifted up 1. So we have an exponential growth shifted up 1, so it looks roughly like that. And we want to know where y is less than -6. So we draw on our line. Notice again, open circle this time because it's just where y is less than 6, not where y is less than or equal to 6. So again, I need to find that intersection. So go ahead, substitute 6 in for y, solve for x. So we have 6 equals 1 plus 4 to the x power, subtract 1, 5 equals 4 to the x, and then convert that to log form. So log base 4 of 5 equals x. So that means our intersection is log base 4 of 5, comma 6, which means our domain is everything from -infinity to log base 4 of 5, because we want everything where y is less than 6, non-inclusive, because just less than 6. All right, given constraints on the variable, graph and then find the domain and range of the solution. So first things first, in order to graph x plus y is greater than 1, that second line, we have to solve for y. So we first start by solving any one of these equations for y that aren't solved for y so we can graph them. So now that they're all solved for y, we can graph. Remember that when you have less than or greater than, it's a dashed line, not a solid line. So all 3 of these equations will have dashed lines. So we have, so we have the line y is less than x, y-intercept of 0, slope of 1, but a dashed line. And y is less than x, meaning our solution's everything below the line. And then we have y is greater than -x plus 1. So that's this line here, y-intercept of 1, slope of -1. So we have everywhere where y is greater than -x plus 1. So that's everything above that line. And then finally, we have y is greater than -2, which is this line right here. Y is greater than -2, so that means everything above it. Now notice this is super sloppy when I have everything graphed. I strongly suggest that you only graph the overlapping parts so that it's very obvious to see what our final answer is. So our final answer is going to be this section here that is below y is less than x, above y is greater than negative x plus 1, and above y is greater than negative 2. So this section right here. All right. All right, so now we need to find the domain and range of the shaded section. So looking at our domain, our smallest x value is right here. Our largest x value all the way to positive infinity. So I need to find what that x value is. So I need to find the intersection of the two lines, y is greater than negative x plus 1 and y is less than x. So we set those two equations equal to each other so we can find their intersection, and we end up getting that that x value is 1/2. So our domain is everything from 1/2 to infinity. And non-inclusive, because if I have two dashed lines, that intersection is not part of the solution. And now our range is everything from the lowest y value, which is right here, to the largest y value, which is all the way at positive infinity. So our range is going to be everything from -2 to infinity. Again, non-inclusive because dashed line means the line itself is not part of the solution. All right, example number 6. X is less than or equal to 5. X plus y is greater than or equal to 5. So we solve for y and we get y is greater than or equal to negative x plus 5. And then negative 3x plus 2y is greater than or equal to negative 6. Solve for y. So we get y is greater than or equal to 3/2 x minus 3. Graph all three lines. So we have our line x is less than 5, which is a vertical line, solid because it's less than or equal to 5. Everything shaded to the left because everything less than or equal to 5. Y is greater than negative x plus 5 has a y-intercept of 5, a slope of -1, solid line because or equal to. And since it's greater than or equal to, that's everything shaded above. And then finally, y is greater than or equal to 3/2 x minus 3, has a y-intercept of -3, slope of 3/2, solid line, y is greater than or equal to everything shaded above. So our solution ends up being the section that is above, y is greater than or equal to 3/2, to the left of x is less than or equal to 5, and above x is greater than or equal to negative x plus 5. I'm sorry, y is greater than or equal to negative x plus 5. So this section right here. All right, so starting with our domain is everything from the smallest x value, which is all the way at negative infinity, all up until this point right here. So that's 5. Inclusive this time because I have the intersection of two solid lines, meaning that that point is part of the solution. So our domain is everything from negative infinity to 5, and that's a bracket there, not a parenthesis. Our range is everything from the smallest y value, so that's this y value right here, to the largest y value, so that looks like it's positive infinity. So I need to find that intersection point right there. So I need to find the intersection between the lines y is greater than negative x plus 5 and y is greater than or equal to 3/2 x minus 3. So we set those two equations equal to each other, solve for x. And I'm looking for the range, not the domain. So that means I'm looking for the y value, not the x value. So now that I found x, I substitute that back in to find y. So we have the intersection of those two lines is at 16/5, 9/5. So that means my range is everything from 9/5 to infinity, inclusive on 9/5 because it's the intersection of two lines, two solid lines. All right, and then our last example 4x minus y is greater than 3. Solve for y, and we get y is less than 4x minus 3. Because don't forget, when you divide or multiply both sides by a negative, you have to flip the inequality sign to make up for the change in positive negative sign. X plus 2y is less than or equal to 10. Solve for y, and we get y is less than or equal to negative 1/2 x plus 5. X is less than 3, and y is greater than negative 4. So we graph our lines, and we have y is less than 4x minus 3, y-intercept of negative 3, slope of 4, and y dashed line because it's less than, and everything shaded below because it's less than. Y is less than or equal to negative 1/2 x plus 5, has a y-intercept of 5, slope of negative 1/2, less than or equal to, so solid line, everything shaded below because it's less than or equal to. X is less than 3, vertical line where x is equal to 3, but dashed because it's less than, and shaded to the left because it's less than. And then y is greater than negative 4 is a horizontal line where y equals negative 4, dashed because it's greater than, shaded above because it's greater than. So our solution ends up being this region right here where everything is greater than, y is less than negative 4, to the left of y is less than 3, below y is less than or equal to negative 1/2 x plus 5, and below y is less than 4x plus 3. So looking at our domain and range, our domain is going to be everything from our smallest x value, which is right here, to our largest x value, which is right here. So I need to find the intersection of those two lines. So I need to find the intersection of y equals negative 4 and y is less than 4x minus 3. So substitute negative 4 in for y, solve, and we get that intersection is at negative 1/4. So my domain is everything from negative 1/4 up until the, sorry, what was that one? That's 3. I have an x here. That's gonna let me, sorry, this should be, I have a y there. This should be x is less than 3. The line x is less than 3. So our domain is everything, again, from negative 1/4 to 3. Non-inclusive because we have a dashed line. So the line, the intersection is not part of the solution. And now our range is everything from the smallest y value, which is right here at negative 4, to the largest y value, which is the intersection right there between the lines y is less than 4x minus 3 and y is less than or equal to negative 1/2 x plus 5. So I need to set those two equations equal to each other to solve for y. So I set them equal to each other, solve for x, but again, I don't want x, I'm looking for range. So we substitute that back in to find y. So that intersection point is 16/9, 37/9. So my range is everything from negative 4 to 37/9, non-inclusive because if one of the intersection points is a dashed line, like this one is, it's not part of the solution because it has to be a solution to everything in order to be a solution to the whole thing. All right, so that was your lesson for today. I should have reminded you at the start of the video, but remember you can always pause, rewind, rewatch anything. I went through this very quickly because I had all of the answers on there already. So this way you can kind of take the lesson at your own pace. If you have any lingering questions on today's lesson, make sure you keep track of those. And I will hope to see you during our office hours on Friday to answer any lingering questions from today and the previous day's lesson. All right. Good luck on your homework tonight, and I hope to see you all on Friday. In the meantime, stay safe, stay sane, and please, 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 please stay distant. Bye.